22 minutes past 7, and the NASA spacecraft Juno has captured the best ever views and sounds of Jupiter as it flew 2,600 miles above its surface.
Joining us this morning, Dr. Jonathan Nichols from the University of Leicester, member of the Juno mission's science team. Very good morning to you.
Morning.
Now, it's probably worth doing, and we've heard it once or twice this morning already. Do we just all pause for a moment and we will listen to the noise?
Let's do it.
So, Jonathan, do you want to explain what we're hearing?
So we're hearing the sounds of the magnetic field from Jupiter vibrating like strings on a guitar. When they get disturbed, they ring, and that's what the sound that we're hearing. It's been changed from radio waves into audio, and it makes that great sound.
What I love is all those people who've worked in sound effects over the years for Star Trek and Doctor Who got the noise right, didn't they?
Absolutely, yeah. If you're going to make up a sound that sounds like space, then that's it.
And do you so the mission itself is ongoing, and also alongside the sounds, we had some extraordinary images. And what is it revealing that we didn't previously know?
Well, Juno is the first spacecraft to go into what's called a polar orbit. So it's the first spacecraft to get a view down on the poles of Jupiter. And it's going to be so close. We've never been that close to Jupiter before. So these images that we're getting are really detailed of the polar storms swirling around the northern pole. It looks like Indian ink on these images that we've seen.
And I think the next pictures we're going to see, the infrared images. Just talk us through what we're seeing there.
So the infrared images are showing us heat from Jupiter. Jupiter's actually hot. It's still hot from when it first formed gravitationally many billions of years ago. And it's like a potato. You heat it up and it stays hot forever. You know, that's Jupiter. And that's what we're seeing, is that heat. But it's not uniform. There are dark regions and there are light regions. And the dark regions are telling us that the heat has been absorbed by clouds. And so it tells us about the nature of the clouds on Jupiter and how the atmospheric circulation works in great detail.
And why is that important? Why is it important that we know that?
So it's important because Jupiter tells us the story of the solar system. It tells us the story of the formation of the solar system and therefore us. So first the sun formed 4.5 billion years ago. And then what was left over, Jupiter formed. And then what was left over from that, we formed. So we're the leftovers of the leftovers, if you will. So knowing where Jupiter formed in the solar system tells us about how the other planets formed afterwards. So it's all about the story of how the planets formed. In order to do that, we need to know about the interior structure of Jupiter and how the atmosphere works and the composition of Jupiter, and that's what the goal of Juno is.
Yeah, and it's an extraordinary achievement, isn't it, what Juno's doing?
Absolutely.
Put it into some kind of perspective for us.
It is amazing, and the images that are coming back are jaw-dropping. There's an image of the auroras as well that just, my jaw hit the floor, and that the team applauded when that image was first shown.
Because presumably, as you're watching, you don't know for sure, A, whether it's going to work, B, whether the pictures have come back intact. A lot of question marks.
Absolutely. So the real tense event was orbit insertion on the 4th of July. I was fortunate enough to be at the Jet Propulsion Laboratory for that. And you could have cut the atmosphere with a knife. You know, it was just... The reason is because we've never been here before. Jupiter is crazy. It's the biggest, baddest, most dangerous place in the solar system. It's really radioactive. We had no idea whether Juno would survive that encounter or not. We didn't have the instruments on, so we didn't know what it was flying through. We had to turn all the instruments off to make sure that there was nothing that could make the spacecraft think, oh, I don't want to fire the rocket, so we had to fire the rocket. This time, it's the first time we've got all the scientific eyes and ears on, and we're getting all the data that tells us about that nature of the space environment around Jupiter.
Jonathan,
fascinating.
Thank you. The baddest place in the solar system.
Yeah,
sounds like a movie.
And also like a potato.
Yeah.
That's
what I've taken from that.
Take home messages. Yeah.
We were really listening to you, Jonathan.
7:27 is the time now.